So let's expand 1 plus x as a power series. One plus x to the negative 2 as a power series, I should say. Well, this is good because this is just a direct substitution, isn't it? If 1 plus x to the k is that, then 1 plus x to the negative 2 would be what? I'll just plug negative 2 in for k, right? Which, I guess that would suffice in some cases, but what we need to do is, on these usually, is simplify that. Sometimes we need to simplify the other, and we'll do that in the next example, but I need to simplify that. What does negative 2n equal? In terms of some real numbers, I guess you might say. Well, that's what we were just doing. Negative 2n, it starts at negative 2, then I go negative 3, negative 4, until I get where? Until I get to negative k, it's k minus n plus 1, so I need to go until I get to negative 2 minus n plus 1, right? And then divide all that by n factorial. Well, that comes out, negative 1 does, to the nth power. Then I have 2, 3, 4, and then 2 plus n minus 1. Which, yeah, I can do a little better on that. That's n minus n plus 1. Okay, pretty good answer. However, let's examine a detail here. What is n factorial? That's n minus 1 until I get to 2, 4, 3, 4, 3, 2, 1, right? That's what n factorial is. What have I got right here? Except for the 1. Don't I have the start of n factorial? 2, 3, 4, 5, 6, 7. Sometimes this, you'll notice if you're just counting up by ones there, this might be somehow where I can simplify this. This, couldn't I say, is basically this on top. Isn't that, of course, times 1, I could put the 1 in there without any effect because it's times. 2, 3, 4, so that's n factorial. But don't I have a little bit more? Wouldn't that be one extra term? In other words, there is an n here, then we have n plus 1. So this right here is n factorial times n plus 1. Then that goes with the n factorial on the bottom and cancels out. So this just winds up being negative 1 to the n plus 1 for this part right here. So wind up with power series wise 0 to infinity, negative 1 to the n plus 1 times x. That would be my power series for that. Okay? They won't all always quite come out because sometimes you'll see with this next one. With the fractions, it doesn't quite work out that nicely. But is that okay? Not too bad, right? Got one more for you All right, let's expand 1 over square root of 2 plus x as a power series. Okay. First of all, I need this to look more like this, right? How am I going to do that? Well, first of all, I probably would want to say 1 over the square root of 2 plus x is 2 plus x to the negative 1/2. Might be a good first step because I need it something to the k power. But they don't like this 2 here, do they? That needs to be a 1. What do I need to do for that? I need to factor off a 2. So let's factor off a 2 off of x plus 2 plus x to make that a 1. What would that make that? X over 2. And that's still all to the negative 1/2. Which we need to realize is 2 to the negative 1/2 times 1 plus x over 2 to the negative 1/2. And so this right here, that can be changed over to my power series. So I'm going to have 2 to the negative 1/2 times that power series with, now notice there's a couple of things here. Instead of x, I've got x over 2, so what do I need to do for x over there? Make it x over 2 to the n. And then my k, what's my k? K is negative 1/2. So I just make those substitutions. This is x, this is k into my binomial series expansion. With me up to now. Is this okay? Look all right? Okay. Well, on these, the idea, next step will be, let's see what negative 1/2 in this notation is going to simplify out to be. What is negative 1/2 in equal? Well, that says start at negative 1/2, then start subtracting 1. So subtract 1 from that would be negative 3/2. Then we'll subtract 1 from that, we'll have negative 5/2. Then we'll subtract 1 from that, and we'll have negative 7/2. Until we get all the way to k minus n plus 1, which in this case is k is negative 1/2 minus n plus 1. Then we'll divide that by n factorial. All right. Well, there's a couple of things I can do with that. I can factor off all the negative 1s. So that's negative 1 to the n. So that'll be 1/2, 3/2, 5/2, 7/2, till I get to 1/2 plus n minus 1. This right here is what, n minus 1/2? Okay. But the other thing we pointed out when we have these fractions is they all have that 1/2 fraction, so I can pull off a 1/2 to the n, can't I? And then I have just 1, 3, 5, 7, all the way until, divide that by 1/2, that'll be 2n minus 1 over n factorial. And so unlike before, where I could cancel, this turned out had some parts of n factorial. This one doesn't have such a thing. The only thing I'd probably do is change that to be 2 to the n on the bottom. Negative 1 to the n, by the way. So it's negative 1 to the n times this 1, 3, 5, 7 business to the 2n minus 1. And then put the 2 to the n on the bottom. Then we'll take that and substitute it all the way back over here for that. And we'll see what we want to do with that. Okay. Oh. There is something we need to mention here. We're saying this is for n equals 0. When we did all this, however, do you see a problem with n equals 0? If I plug in n equals 0, that's going to give me what right there? Minus 1. Do I even start with minus 1? So that makes no sense. So this works for everything but n equals 0. Because I just can't plug in n equals 0 there because it gives me a negative 1 and I don't have possibility of, I mean it works for 1 because that would give me 1, but negative 1 doesn't make sense there. So with that in mind, here's what I'm going to do. So I'm going to come back here and say, well, this now is 2 to the negative 1/2 times the series this all over n factorial, 2n, 2 to the n times n factorial. And then we got x over 2 to the n over here, except for n equals 0. So actually, sorry, I need to separate out n equals 0 right here. If I've got n equals 0, then I'm doing 2 to the negative 1/2 times negative 1/2 0 x over 2 to the 0. So I just need to do that separate term, and this term, so this one comes out to be n equals 1 to infinity. So I have to make a little bit of an adjustment there because it doesn't work with n equals 0. All right, well that's 1, that's 1. So this is just 2 to the negative 1/2. The first term is just 2 to the negative 1/2. Now, do you see anything I could simplify with this big mess right here? Well, notice over here, I've got 2 to the n there, and then I've got another 2 to the n here. So I've got a 2 to the n times another 2 to the n. What is 2 to the n times 2 to the n? Four to the n? The 4 to the n? 2 to the 2n, which isn't that 2 squared to the n? 4n? 4 to the n? Okay, so we got 4 to the n there. Something like this. That's probably about the only thing I can say we could do here. Make that just x to the n, and then combine the 2 to the n there with 2 to the n there, so we have 4 to the n, and then n factorial. But yeah, you gotta be careful with that 0 term. Sometimes it doesn't follow the same guidelines there. But anyway, fun stuff. This is just x to the n here. Yeah, okay. All right, there we go. There it is.